The John Hancock Center, located in Chicago, Illinois, stands 1,127 feet tall, and in 2005 is the fourth tallest building in the U.S. Known affectionately as Big John, it's a 100-story mixed-use building. That means it houses both residences and businesses. As in most U.S. buildings, the street level is the first floor. Another floor up is the second floor, and so on. Big John goes up to the 100th floor. Each floor level can represent a positive integer. But the Hancock Center also has a concourse level, which is one floor down from street level. Based on its location below the first floor, it can represent 0. If you live on the 63rd floor, you are 63 floors away from the concourse level, or 0. We can see this on a number line. The numbers to the right of 0 are positive integers. When you are at the swimming pool on the 44th floor, you're 44 floors or units from 0. A number line representing all integers also extends left of 0 to represent the negative integers. The integers are the whole numbers and their opposites. Some buildings have several subfloors, floors that are underground. This building has parking on the levels below ground, labeled as P1 and P2. Since they are below 0, they can be expressed as negative numbers on the number line. Now P1 and the first floor of this building are both the same distance, 1 unit from the 0 floor. P2 and the second floor are both 2 units from 0. Numbers the same distance from 0 in opposite directions are known as opposites. Absolute value is the distance an integer is from 0. Whether the integer is positive or negative, its absolute value is always positive because distance can't be negative. So the absolute value of 3 and negative 3 is positive 3. Let's look at some other properties of integers. Every year, the John Hancock Center in Chicago, Illinois, has a foot race up to the observation deck. The participants climb the stairs from the first floor to the 94th floor, if they can make it. The floors are like positive integers, or positive whole numbers, except that positive integers can go on forever, so there is no greatest integer. For any integer you can think of, you can add 1 to it and get a greater number. The floors in the race only go up to 94, but they probably seem to go on forever to some of the racers. Integers are the whole numbers and their opposites. They include positive integers, negative integers, and 0, which is neither positive nor negative. Positive integers can be used to count things. We can count the number of floors in the race from 1 to 94. The racers count the floors as they reach them, so they know how many they've conquered and how many they have left. But for many, as they approach the top, the running and counting slows down, and the racers start counting fractions of floors. This worn-out racer has climbed 50.5 floors. That's a mixed number, an integer with a fraction. Integers can be considered as place markers on a number line, but any point on a number line can be considered to have an associated number, most of them between the integers. For example, the point halfway between 50 and 51 would be the mixed number 50.5. Halfway between 50 and 50.5 would be the point corresponding to 50 1/4, a quarter of the way from 50 to 51. The fastest racers make it to the observation deck in about 10 minutes, which is about 7 seconds per floor. The average race time is 26 minutes, about 17 seconds per floor. And the others, well...
How'd you do?
There are very few places in the world where you can live on the 92nd floor. The John Hancock Center in Chicago is one. With 100 floors, most of the building is beneath floor 92. Let's compare the building's floors to a number line. If we go from the apartment on the 92nd floor to the grocery store on the 44th floor, how many floors have we traveled? Positive and negative numbers have not only magnitude, but also direction. So, to get from floor 92 to floor 44, we can subtract one positive number from another, or we can add a negative number. The two approaches are equivalent. 92 plus negative 44 equals 48, just as 92 minus a positive 44 does. Subtracting an integer is the same as adding its opposite. Now, back to the number line. Since the 92nd floor is home, let's change our frame of reference and call that 0 now. There are 8 floors above this 0, positive integers, and there are 91 numbered floors below 0, negative integers. Now, if we go to the 44th floor, we've moved from home, our new 0, to negative 48. Its distance from 0 is 48 units, but it's on the negative side. The distance from 0 is the absolute value of the number, whichever side it's on. The opposite of negative 48 is 48. They are the same number of units away from 0, but on opposite sides of it in opposite directions.
Bye.
But if you take the stairs, 48 floors is a long way from home. The John Hancock Center's X-shaped bracing makes it one of the most recognizable buildings in the world. It was built this way to get the most space on each floor. The exterior bracing blocks several of the windows. Those beams are actually a status symbol. We can see a way integers are used by looking at the building's windows. In this section, there are 8 windows across between the vertical beams. If we go up 3 floors and over 8 columns, we have a block of 24 windows. That's 3 times 8. So, 24 is the product of those two integers, 3 and 8. It also means that 24 is a multiple of each of them. A multiple of a given number is the product of that number and a whole number greater than 0, a positive integer. Other positive integers can be multiplied to equal 24, like 1 and 24, 2 and 12, or 4 and 6. So, 24 is a multiple of each of those numbers. A factor of a whole number is a positive integer that divides it without a remainder. Since 24 divided by 3 is 8 with no remainder, 3 is a factor of 24. So is 8, because 24 divided by 8 is 3 with no remainder. 24 divided by 4 is 6, so those numbers are factors also. A product of two positive integers is a multiple of each of them. Knowing how to find common multiples and common factors is useful. For instance, to add and subtract fractions, you need a common denominator. To add 5/6 and 3/7, we must find a number that's a multiple of both denominators, 6 and 7. 6 times 7 equals 42. Multiply both the numerator and the denominator of 5/6 by 7 to get 35/42. Then, multiply both the numerator and the denominator of 3/7 by 6 to get 18/42. So, 35/42 plus 18/42 equals 53/42. Since the numerator is more than the denominator, we can make it a mixed number, 1 and 11/42. Rational numbers can be expressed as a quotient of two integers, a divided by b, where b doesn't equal 0. Since fractions are all expressed this way, all fractions represent rational numbers. Any whole number, of course, can be expressed with a denominator of 1, with itself as the numerator. Here's how these types of numbers relate to each other. Natural numbers are the set of counting numbers. Whole numbers are the counting numbers and 0. Integers are whole numbers and their opposites. And all of these, with fractions, are rational numbers. See how larger sets include smaller subsets? Good. Now let's move these numbers out of the way and enjoy the view.